Alright, so this is a lesson over square root functions. So now the points that are relevant for this graph are these. Alright, now notice that I picked 0, 1, 4, and 9. And the reason I picked these x's is because if I take the square root of 0, I get 0. If I take the square root of 1, I get 1. If I take the square root of 4 is 2, and the square root of 9 is 3. Now remember that to get this y values, really all you have to do is plug in the x values into here. And these are the easiest x values that you can take the square root of, right? Now the graph is going to look like this. Notice that it's almost like a parabola, but kind of sort of laying on its side. Now the domain for this starts at 0 and you go to positive infinity. So you can either write it like this, x is greater than or equal to 0, or if you choose to, you can write this in interval notation like this, including 0 and all the way to positive infinity. Remember, infinity is not a number that can be included, so it's always with a parentheses. Right, for the range is going to be the same thing. I start here, and now as this graph keeps going to the right, it keeps going up forever. So this one's going to be y is greater than or equal to 0 for the range, or you can write that as between 0 and positive infinity also. Now we're going to go over a few of these translations for this graph. Now if you have a negative in front of it, what's going to happen to this graph is that it's going to look like this. And again, I'm just doing a sketch here. It's going to look something like that. Alright, so what really happened to this one is that this, compared to this one, right, if you're comparing this graph to this one, you have a reflection over the x-axis. Now, on this one, if you put this in your calculator, right, and I welcome you to go ahead and put that in your calculator if you have one, if you have a graphing one, is that it's going to look like this. 1, 2, 3, 4, 5. Okay, it's going to look something like that. Alright, now the reason that it looks like that, think about it, right? I went to the left 5, right? So if I went to the left 5 when this is a plus, what do you think is going to happen on number 4 when I have x minus 1? If you put that on your calculator, you're actually going to move to the right one spot like that. Okay? Now, if I have a square root of x minus 8, right, this is what's going to happen to the graph. It's going to look like that. Alright, notice that compared to the parent function, this function right here actually went down 8. Okay? Now, if I have a plus 3, then what's hopefully you're seeing the logic behind this is that this is going to, the parent function is going to move up 3. So it's going to look exactly like this one, just the only difference is that this graph is going to be translated 3 spots up. So that is what it looks like. Okay? Now, finally on this one, alright, notice that you have a 2 in front of the square root. So what happens with this one is the following. It'll look like that. Alright, so notice that the difference between this one and the parent function is that it looks like this one was stretched, alright, vertically. So in general, alright, what's going to happen is if you have a negative outside the square root like this, that's going to make the parent function reflect over the x-axis. Alright, if inside the square root you have a plus some number, alright, you're actually going to move to the left, which is perhaps counterintuitive. Right, and this one, if you have a negative, if you have an x minus some number, that's actually going to move to the right h units. Remember, h represents some number. Alright, so notice that this is kind of counterintuitive, right? Now the reason that I remember this is because some catchy phrase that I've heard some time ago that says that your x, whatever is in here, your x is a liar, so it's always going to tell you the opposite. If this says plus, you're actually going to move left. If it says minus, you're actually going to move to the right. Okay, so on number 11, if you have a plus k or plus some number outside the square root, that's going to move this parent function up k units. If you have a minus, it's going to move it down. Notice you have a minus outside the square root. And then finally, if you have a number, this a represents some number. If that number is greater than 1, then you're going to have a vertical stretch. Again, only if that number is greater than 1. Notice that I put the absolute value of a. So even if you have a negative here, if you had a negative 3, for example, that's still the absolute value of negative 3 would be positive 3. So that's going to be a vertical stretch. It's almost like you're grabbing that graph and you're stretching it vertically. All right? Now, if this number right here is less than 1, then you're going to have a vertical, some people call this a compression or a shrink. So it's going to shrink if that number is less than 1. So if you get like if this number would have been a half or a third or anything less than 1, then that graph would have been shrunk like this. So actually, when you do that, you're actually compressing it. Okay? Now we're going to go over some examples on the back. So now this has a combination of many translations on here. Okay, so let's first look at it. Like on this one, they're asking you for what are the points for the parent function. Not this one, but for the parent function. And it's going to become useful for you to remember these, because that's going to make your life a whole lot easier. At some point, we're going to graph these without a calculator. All right, so that's what we got. Remember, these are the same points that are on the first page. Okay, so now let's talk about what's going on. Remember, if you have a negative in front of the square root, that's going to make this reflect over the x-axis. Okay? Now that minus 3 is going to make this function go to the right 3 units. And then finally, this plus 4, this outside the square root, is going to make the graph go up 4 units. Okay? And then we'll take care of the domain and range as soon as we graph it. Okay, so this is how you do it, all right? Instead of you trying to figure out, okay, if you're doing this by hand, remember, instead of you trying to figure out, okay, what points did I plug in here to figure out what to graph, okay? The way you need to do this is that we're going to start right here. We're going to go right 3 units from the origin. We're going to go right 3 and up 4. So notice that right here, I actually have a point. Excuse me. So I actually have a point on the graph right here. So that's actually going to be my starting point. We're going to call this the fake origin. All right, so from there on, instead of me trying to figure out how to graph this is going to be almost the same thing as graphing the parent function. Now the only difference is that because you have a negative in front of it, you're basically going to multiply each one of these by a negative 1. All right, notice that will give me still a 0. Get a negative 1 here, a negative 2, and a negative 3. Okay? So from this point, that's point 0, 0 for me. Right? That's my fake origin. That's point 0, 0. Okay, my second point should be 1, negative 1 from the fake origin. Not from here, but from here. So from here, I'm going to go to the right one, right? That's x 1 unit to the right, and then 1 unit down. And that's going to be my first point. Right, my second point from the fake origin is going to be 4, negative 2. So from the fake origin, from here, I'm going to go to the right 4, and then down 2 because you have a negative 2. So I'm going to go below. So again, what I'm saying one more time is you're going to pretend as if this is your origin, and you're going to follow the same table as the parent function, all right? And then finally, the 9, negative 3, I can't really put that on the graph because I'll be off the graph. And then you just connect the dots. Okay, now let's look at the domain. The domain actually starts at 3, So we can write it as x is greater than 3, greater than or equal to 3. Or you can write it in interval notation as 3, including 3, all the way to positive infinity, right? Because that arrow points towards positive infinity on the x. Now for the range, I'm trying to figure out how far up and how far down I go, right? Now notice that this is not going to go any higher than this. However, as this goes to the right, it's actually getting lower and lower and lower. So the way we can write this, we can write it two ways. We can say that y is less than or equal to 4. Right, it's less than 4 because 4 is right here on the y-axis, on the y, and it's going to keep going down. Or we can write it as, we always want to go from the bottom up on here, so we're going to write between negative infinity and, in this case, positive 4, including 4. Okay, so that's that for that. Okay, now let's look at 15. Same idea, right? Now let's talk about all the changes that are happening, all the transformations that are happening here. So notice that that right there is going to make it a vertical stretch by a factor of 2. All right, so we're going to stretch this by a factor of 2. And remember, I'm calling this a stretch because this number is bigger than 1. All right, remember x is a liar, so this is going to be left 1. And this is going to be down 3. Right, so it'll be better for you to try to figure out what's going to happen first before you actually start trying to plot points on the graph, all right? Again, I'm going to rewrite the same numbers for the parent function y is equal to the square root of x. Now, before we begin, all right, let's look at the stretch. What's going to happen is that this vertical stretch is going to make only my y value, not my x value, only my y value, all of those are going to be multiplied by 2. Okay, so when I get that, I would have a 0, a 2, a 4, and a 6. Okay, so that's what I would have. Excuse me, that was a bell for lunch. Anyway, so these are my new y values that I'm going to be following, all right? So remember, the first thing you need to do is find your fake origin, and that's going to be found by finding out how far to the right or left and how far down or up from the function, all right? So now we're going to go left 1 and down 3. Left 1, down 3, all right? So that's where my fake origin is going to be located. Now from this point on, I'm going to pretend as if that point right here was my origin. I'm going to pretend like that's point 0, 0. So notice I already plotted the first point. That's 0, 0. That's my fake origin. My second point should be 1, 2. All right, so from here, if I say that this is 1, excuse me, if this is 0, 1, 2 would be right here. Over 1 up 2, right? Now the second point should be 4, 4. So from here, from my fake origin, I want to go 1, 2, 3, 4, and then up 4. And then finally I have 9, 6. So from this point, you're going to go over 9. 9 is right there. And then up 6. All right, so pretend again that that point right there was 0, 0. So that point right here would be 9, 6. Connect the dots, and that is the function. We just graphed that function. All right. The domain again, notice that we start at -1 and we go to the right. So you can either write it as y is greater than or equal to -1, or you can write it as between, including -1 to positive infinity. For the range, notice that the lowest point on here is -3. And then it goes up. So this would be y is greater than or equal to -3. Or, so again, you don't have to write both. You can only write one if you like. Or you can say that this goes between -3 and positive infinity. Okay? So that's how you graph those. Now, if they're making you write an equation, all right? Write an equation, and you're going to start with this. All right, so remember, this is the parent function of square root of x. Now, if they tell you to shift 2 units to the right, that means that y is equal, remember, 2 units to the right means that when I have an x minus 2, remember, because I want to write whatever is opposite of this, right? If it says right, I'm going to go left. And 4 units up. Make sure that that 4 units up needs to be outside the square root. And that's it for that one, okay? Now the next one says shrink by a factor of 0.5. Now remember, the reason that says shrink is because the factor, this, 0.5, is less than 1. So all you do is you need to write that number in front of the square root, okay? I'm going to write the square root of x. I am not being shifted left or right, so that's it for that. And I'm going to go up 3 units. So I'm going to write that 3 outside the square root. All right, number 18. Now it says reflect across the x-axis. Remember, when you reflect across the x-axis, you're going to put a negative in front of it, okay? And then it says stretch by a factor of 3. Remember, it says stretch because this, the factor, is 3. Now it's more than 1. Right? So we're going to stretch by a factor of 3. So all you have to do is write that number in front of the square root. And then now it says we're not moving left or right. All we're doing is shifting down 1 unit. So we're going to subtract 1. And that's it for that one. All right, now on 19, see if you can do it yourself. You can pause it. Now, assuming you have tried this, right, and this will go a lot smoother if you try it before you get to class. We're going to reflect across the x-axis. So we have a minus. It says stretch by a factor of 2, which means I'm going to put a 2 in front of the square root. Now it says, and 5 units left. That's going to go inside the square root. Now left means I'm going to put a plus 5. Remember, x is a liar. And then finally 3 units up. So I'm going to write that 3 outside the square root. All right, finally, if they give you a graph and they're asking you to write an equation, it's actually very simple. The first thing you have to do is find your fake origin. Where does it start? So notice if you have looked at the parent function, this is basically my fake origin. So I have to go count it. It goes 2 to the left and 2 up. Okay, so I go 2 to the left and 2 up. And also, if you notice, if you're comparing this to the parent function, remember the parent function, in case you forgot, looks like this. Compared to that one, this is actually being reflected over the x-axis. Okay, so I'm going to write a negative here. And remember, how many units did I shift to the left? 2. So I have x plus 2. Right, how many units up from here? I went up 2 units. Right, remember, I put a plus here, plus 2, even though I moved to the left because x is a liar. Now, finally, the way to tell if something is being stretched or not, if you're just looking at the graph, just look at the first point. If this is 0, 0, that looks like it's 1, negative 1. Okay, well, therefore, it's not being stretched. I would know just by looking at the first coordinate. Okay? Now, if you have any questions, make sure to ask us tomorrow when we see you.